Hello everyone, welcome back to General Mathematics class. We continue to the second video on graphing rational functions, and I will be giving you now the second rational function. Our second rational function is f of x is equal to x cubed over x minus 1. We now proceed to solving its x and y intercepts. Again, in solving for the x-intercept, we substitute y with 0, so we now have 0 is equal to x cubed over x minus 1. Then we multiply x minus 1 to both sides of the equation, giving us 0 is equal to x cubed. To solve this, there is no need to factor out x cubed, but instead, we get its cube root, which is x, giving us 0 equals x. And like the previous example, we have x-intercept of 0, 0, which is found on the origin. To solve for y-intercept, x should be equal to 0. That means we have y is equal to 0 cubed over 0 minus 1. To simplify, we have 0 over negative 1, and simplifying this further is 0. The resulting equation now is y is equal to 0. Again, another y-intercept is located on our origin. So if you notice, once our x-intercept is at the origin, it also follows that the y-intercept may be located at the origin as well. We now proceed with the asymptotes, and first off, vertical asymptotes. Since x cubed over x minus 1 is already the lowest form of the function, there is no need to reduce it anymore. Using the denominator x minus 1 and equating it to 0, our working equation now is x minus 1 is equal to 0. Then solving for the value of x, we have x is equal to 1. This means that our vertical asymptote is represented by the equation x equals 1. We then proceed with the horizontal asymptote, and now we need to identify the degrees of the numerator and the denominator. Recalling, the degrees are the highest exponents of the variable x on both numerator and denominator. The degree in the numerator is 3, while the degree of the denominator is 1. Upon comparing, we can see that the degree of the numerator is higher than the degree of the denominator, which means that automatically our horizontal asymptote does not exist. And since the difference of the degrees of the numerator and denominator is not 1, it also follows that the oblique asymptote does not exist. This means that neither horizontal nor the oblique asymptote exist for this graph. You will be seeing a screenshot from Desmos.com to check if the graph of our rational function follows the values that we have solved previously. Here, upon checking, you will see that the graph intersects our x and y axis on the origin. Also, there exists an imaginary vertical line that both portions of our graph are approaching to but cannot touch nor reach. And that is now the graph of our second rational function. Please watch out for the third sample of graphing rational functions. See you in class!